Martin, can you talk us about a really deep neural net?
Yeah, thanks a lot. So I will talk about investigation we did to compare a deep neural network made on actually 150,000 data, the network I decided to investigate a little closer here. And I will compare it with, well, to start with PLS, but also with all of our current model that was sort of in the products we combined here. And I tell you my conclusion already, and my conclusion is that I think there is a space for deep neural network in at least the type of work we are doing. So let me see if I can get you to that conclusion through my talk here. Maybe a little about myself, so you know where I'm coming from and my biases. I think Harald knows my biases because we've been talking about ANN since the 90s. And that's when I started doing ANN. I did my PhD in theoretical physics, where I focused on it. There was a time back then where ANN was really popular as well. And it's coming back now. And maybe this wave is even more interesting than the last one, but I'm from the last wave, so to say. All right. And we've always been looking at what I call universal models, spanning huge varieties. I mean, starting out by saying, can we do one monogastric calibration? All the monogastric feeds into one calibration, or the ruminant, or forestry, or whatever. But taking that to the limit, including all parameters we can do, or one parameter for all products, that would be nice for several reasons. I mean, for one, it could be convenient. We have one model for everything, yes, point and shoot, or, you know, that could be easy, if it works well enough. But it's also, I know Tom won't like that, but okay. But also, it's sort of a baseline. So when we do a local model on a single product, that must be better than universal, right? So it's always something I can tell my people in my team, if you don't beat this model, I mean, go home, basically. Not go home, but do it better, or use the universal, right? And another is sort of opportunistic replace calibrations. If I have a customer calling me tomorrow and say, I want to do this exotic product, do you have anything? Well, we don't, but we have the universal one. So it's a good starter. It's for collecting data. It could be that I have an older model that we developed many years ago that hasn't been updated. And then maybe the universal is better because it sort of has all the current data. So there are places where a good universal model would be good for the type of work I'm doing. All right, and now this deep artificial neural network came into the picture a couple of years ago. And then, of course, it's interesting to see, would that be a better universal model than the one I can do with my tricks I have today, so to say. So that's what I will compare with here. And the data I have is from our DA series of products. There is a bench, there is an overbelt, and there is an inline. And as I said, 150,000 spectra went into the model building. It's data from 950 and 1650 nanometer. And I'm looking at moisture here. This is the distribution of the moisture values for the calibration data. And of course, it's quite heavy on the low side, but we just fed all the data in. And then we have different test sets for different products. Some of them, they are what I call closed. That's from the same sort of, you mix it on the table and save 10% or something. But some test sets, they are really different. They are from another country, from another harvest, or from a year later than the model was developed, etc. So it's a mix. The test set is a mix. And the test set is around 30,000 data in total for all these products. And of course, you always start with a PLS, or I do at least. And if you take all of this data, predict, you do a totally linear, no pre-processing at all, in fact. Just the PLS, I use a lot of factors, 25. I know you won't like that, Harald, but it gets worse if I have fewer, I promise. Anyway, that's totally linear. And then, of course, PLS is a game of fiddling with the data before you apply it. I mean, if you want to do an MSc, you do that. If you want to do something else to massage the data to be a little more linear, you do that. So I played around with that a little. I found that I did a Savitsi-Goulet, a Ditran, I think it was second derivative, and an SMV. Then I arrived at this instead for my global model. And that's a lot better, of course. The problems with predicting negative, I could easily fix. Just saying negative is 0, so this end isn't as bad as it looks, so to say. So then I have something, a universal model doing something at least. But then if you know me, my go-to model for big data set is always the normal ANN. And I saw someone refer to them as a shallow ANN. And I had some idea about doing linearization on this. That's why I picked exactly the same as PLS. So the only thing I did for the ANN here was to add a hidden layer with 8 neurons. Otherwise, it's the front of the network is exactly the same pre-processing. I used the PLS compression as an input for my ANN. So it's only 8 factors more. And then I get this universal model, and that's much better than the PLS. So this is fairly okay. That could serve my purpose. But now, what could I do with a DNN? I'm not the expert on DNN, but we have a team in Perten, an AI team that are experts on different types of deep neural networks. So I worked with them. We started this a couple of years ago, and they've done a lot of different DNNs for me. And now I investigate one of them. They are so secret about what they're doing, so I won't tell you any details about the DNN. I will only tell you about how it compares, right? But this is what I was allowed to talk about. So I'm allowed to say it's a dense network setup with convolution operators. The blue ones here. This is blurred by purple, so you can't zoom in to see what's in the boxes. And they also spend a lot of time on genetic algorithms to optimize the whole architecture. Yeah, and I forgot to tell you, if you're not looking at my slides, you can look at least the part 2. That's a series by itself, but I won't mention it. All right, so here's my ANN again, just for comparison, my universal ANN. And this is the result of the DNN I got from the AI people. It's beating my model with 18%. That's usually what I beat PLS with. So I'm impressed, right? I made a career of beating PLS with ANN. And somebody's doing this, that is beating me. Okay, I will of course argue that it's not reasonable to do a model spanning all the way from, German sausages to sawdust, right? That doesn't make sense. No customer is that wide anyway. All right, but that's also the argument I use for PLS. I mean, you could do a good PLS with all of these products. The problem is you would need maybe 100, and I can do it maybe with, 10 ANNs or something. Maybe these guys can do it with just 1 DNN. So it's the same kind of argument, just going one step further. So this is interesting. It's interesting as such, as a universal model, so to say. Oh no, I made a mistake. That was the hardest thing. Okay, let's go to this one. Yes. I was trying to study the previous speakers. That's what I was more nervous about. Okay. So the next question is, could I actually use this, not just as a universal baseline model, but could I actually use it for exchanging some of the models we sent to me or give away with the instruments? So here I did a more detailed study on, I think it was like 22 products. And I divided the SE for the DNN with the legacy. So if you're below the line here, then the DNN wins. And if you're above, the legacy wins. Legacy is not a good word. The AI team, they said, they called all of our previous model legacy. I guess they just thought that once this hit, everything we did before is legacy. But these are actually the current models, right? So what named legacy is the current models, right? But could I exchange some of the current models for the DNN? If I look at the accuracy for these 22 products, I studied a little more in detail. There are certainly a few that's better. Some of these, like this one, I took a closer look at. Turns out that it's a pretty old model where we actually have a lot of new data that was included in the DNN, but the local model, the model for that product, did not have that included. So the local model could be better. So there are things like that. But I mean, if I'm in a position where I have to send a model tomorrow, I have an alternative to choose from here, right? And it's not all about accuracy, of course. There are so many other things that are important. So you actually have to know the customer, how will they use the model. But to get some idea about other things than accuracy, you could study a few different robustness sets here. So I have a few sets for repeatability and transferability. That's how it predicts on another instrument, and some temperature. And also remember, we have three quite different instruments in the data here. We have the at-line, the in-line, and the bench one. So I mean, transferability could mean between those platforms as well. And in general, this DNN, compared now with the product-specific models, are doing fairly well, except on temperature. So I spent one graph here on temperature. So this is 10 different products where I have good temperature sets. And again, I divide, now I'm looking at the root mean square error, not bias adjusted, because normally a customer don't want to have different models for different temperature. If they bring in grain from the field, they will want to use the same calibration as if they take it from a cold storage. I mean, it's not feasible to have different calibrations or bias adjust, usually at least. So it could be important. And then you see some models, it's going quite good. Some models is the same. And a few ones are really bad. But looking closer into that, that's a special situation where we actually spend a lot of energy in doing the current model, not a legacy. This will certainly not be a legacy model. I want to exchange that, right? And we use a lot of trick when we have to deal with temperature or other variation. EPU is one of our favorite tricks. We have a few more. We didn't apply that for DNN. You could, of course, right? But we didn't do it. So that might be some explanation. So I think that's basically what I plan to do in my 10 minutes, leaving some for question. But my conclusion is that always do a PLS. I mean, that's what I compare with all the time. And if you have a simple product, you don't have to complicate it. And if you don't have to complicate it, don't complicate it, right? Right, so I always do PLS to compare with. And ANN is my favorite go-to tool if I have at least 1,000 data or a specific reason to use it. And it's very nice in the sense that I can cover more products. So instead of doing 10 single PLS to divide some complex feed group, I can do one. So that's easier, better for many reasons. And I think the DNN deserves a place in my universe at least, because it seems to be even more powerful for this huge variety. And I'm sure there are many things to learn. Maybe we should do some pre-processing. Maybe we should do EPU before to take care of temperature. I don't know, but I mean, from this simple experiment, it does show some benefits. So I will keep it in my book of tricks for doing calibrations for the field. All right, that was it.
Questions? Antonio?
Okay, so thank you for the nice presentation. Just a question. Coming from industry and having access to so many data, I got a little confusing. Do you recommend the DNN, or you plan to use it because we didn't saw the architecture, or you stay with the classic? What are your feeling? Do you think that is the future? You addressed what Dario was saying about the tabular data that we cannot understand.
My feeling right now is that if you have data enough for a specific customer, you know what that customer is doing, then usually, if you spend time enough, it's better to do something on that product and put energy into what variation do you need to cover, etc. I mean, tailor-made, that's usually the best one. But sometimes you don't have time. Sometimes you really want an instrument that covers many products because ease of use is more important than a few decimals more on the SCP. But in practice, most of what we have today out on our instrument is classical methods, and then it's PLS, ANN, or HR. We might have a few of these DNN out there, more of the reason that, well, a customer needed something quick that is working decently. Yes.
Okay.
So I was wondering, so the image analysis people work a lot nowadays with pre-trained models. And I was wondering whether your universal DNN offers a possibility to kind of get a pre-trained universal model on a wide range of products, and then with fewer than the 100 PLS samples we have now, kind of fine-tune it on the application you're looking at. Can you comment on this?
Yeah, absolutely. I mean, there are tricks to fine-tune a universal ANN towards a specific product group, but there are even more things done for the deep neural network to sort of adapt it to a local scenario. So we are playing around with that. I don't dare to say too much about it, but there are things you can do with just like the big language models. You can have a well-trained one, and then you retrain it, repurpose it a little, or specialize it. So there are all things like that you can play with, absolutely, and it's interesting. Yes.
So, as this one point, so your neural networks is correct that they were trained from all data, so you don't have it separate.
No. Right. So what I call the universal models, they were all trained on exactly the same data as DNN, the deep ANN. So also the PLS I showed in the beginning, they were all trained on this 150. But then I compare with the legacy ones, the current ones, because that is also interesting. But this ANN I showed here, plots on, that was the universal. But some of the legacy ones, they might also be an ANN. I mean, I know, for instance, for the monogastric feed, we have an ANN. For the ruminant, we might have an HR. So the legacy ones, they could be whatever. That's the model we sell today. Yeah.
So then, when you take out one product and then try to bring this product while the model is based on the other products, also, so that's the way you do this. I mean, you had several products, isn't it? Where you were comparing very diverse data, as I understood.
And here I was aiming at comparing with what we sell today. So I didn't redo it on the same data that went into the calibration. I mean, I could have picked out those belonging to that product, making a specialized model for that product on that. That would have been interesting as well as a comparison, but I had a more practical idea here. And yes, see, with the range of product calibrations we sell today, how does it compare with that? Because I see an opportunity. If we have an old model that hasn't been updated for a long time, could this universal model just replace it until we have time to do something very specific? So that's what I was doing. So I didn't do the comparison where I optimized it for each product. I did it for a few just to test, and then I found out that, you know, there is 2,000 more data that wasn't used for the one we sell today. And if I include that, that gets better. So I did it in a few cases, but not in general.
Hello. Two things. One, to the organizer. There are so many beautiful lectures here. Do you really get access to them afterwards as PDFs?
If the speakers allow them to be transformed into PDF.
It would be very wonderful, I think. It's just a joy to sit and listen.
And we are supposedly recording this. So I will only know how it gets after I download it from the central computer. So let's see if we can post it online after.
Very good. Second one is that when you have, especially at the end, there are a number of parameters to tweak in order to optimize it. Are people using this strongly reduced factorial design, statistical designs to optimize it, or are you letting the computer run for 2 weeks? Now these OLBR or Latin hypercube and these things that where you only have 0.1% of all the work done, and you essentially get everything you need.
I don't really know what our team was doing, but they are working with NVIDIA, so they have access to these newest, biggest NVIDIA stations. So I don't think they care too much about computer power.
But then I must have a third comment. Something one, your country developer. He said that in the 80s, when he was working on an ABC computer, developing the SIM protocol, he said that anything that cannot be done in multivariate analysis, anything that cannot be done on an 8-bit computer is without scientific interest. And he said that because people were replacing scientific inquiry and trying to understand with more computer power, already in the 80s. Don't forget that.
Yeah.
It's not science if you do it in a black box.
Just a quick comment, your choice of sawdust and sausages is the extremes. So for me, a touching faith in what goes into sausage.
I was actually thinking about making a joke about that. And then I was thinking, oh, I have more Germans or more English, what should I do? And then I can't skip the joke. And I have one comment for you, Lola. The A&M I train here is pretty similar to what we did, 11 by Mach Walls, etc., back propagation, pretty much the same setup. I have much fewer neurons here, even if I have a lot more data. So maybe you were overshooting a little. And also on my laptop, it took like 2 minutes to train my neural network. So speed is not a problem for the shallow network these days, at least.
Yeah, most of I think that your AI team there, they did what I would like the community to get together and do a little bit, which is craft an architecture for, in this case, the specific spectrum from those instruments, right?
Yeah.
So this is the thing that they invested a lot of time using genetic algorithms in order to get the number of layers and all of this. I've been working on that as well. I usually research or Bayesian optimization to do the neural architecture research. And yeah, that's where the time-consuming part is, because training the neural network now on a small PC, with a graphics card that kids used to, not kids, we also like to play games. It's really fast. So I guess that the network that Lola trained for 20 hours, like 15 years ago, would be like 30 seconds today.
Yes.
Most probably.
Yeah, and it would be really nice. I mean, if we come to a customer with a new product, they have 100 samples, then we would typically do a PLS, massage the data, try to understand it, and have a decent product calibration. What happens if you take this big DNN, we train it, repurpose it a little towards these 100 samples? Would that be better? I mean, then we have a very fast method to generate good, stable models. I leave it to that, I guess. There are opportunities out there, I think. Yeah.